Hello all, today's topic is that how to design a singly reinforced beam section. So in this question here you can see from the above question the given data is width of the beam is 200 mm. So here you can see the width of the beam is 200 mm and effective depth is that 400 mm. So 400 mm effective depth which is reinforced with 4 bars of 16 mm dia. This beam is reinforced with 4 bars which is of 16 mm dia. So the grade of steel used is that yield strength of steel is 415 steel Newton per mm square, and concrete used compressive strength of concrete is the grade used is M20, so 20 Newton per mm square. So by assuming the effective cover of a beam is that 20 mm. So to find the capital D, the formula is that D plus effective cover. D is nothing but effective depth. So effective depth is 400 mm plus this 20 mm is effective cover, which is that capital D we will get 420 mm. So now we will find for area of steel. Area of steel formula is that pi by 4 D square. But here the bars used is 4. So into 4. 4 into pi by 4 into the dia of steel is that 16 mm. So 16 whole square. So we after doing this calculation we will get 804.24 mm square. So the area of steel is that approximately 805 mm square. So now we will do compressive force equals to tensile force. So compressive force formula to find for a singly reinforced beam is that 0.36 FCK into B into XU is equal to 0.87 Fy into area of steel. So 0.36 into FCK is nothing but M20, which is 20 Newton per mm square, into B. B is 200 mm into XU, which is limiting moment. So equals to 0.87 into Fy is 415 and area of steel is that 805 mm square. So XU equals to 0.87 into 415 into 805 divided by, we are doing this portion to divide. So we will get XU equals to 201.83 mm. Now what we will find XU max. To find XU max for a Fe415 steel, the formula is that 0.48 D. So 0.48 into D is that effective depth, which is 400 mm. So 400 mm. XU max equals to 192 mm. So if XU is greater than XU max, then the section of the beam is over reinforced beam. So this beam is over reinforced beam. So here you can see XU is the 201, which is greater than XU max. So this section is over reinforced beam. So to find MU, the formula is that 0.36 FCK into B into XU max into D minus 0.42 XU max. So 0.36 into B is nothing but 200 mm. FCK is that 20 into XU max we got is 192 mm into D. Effective depth is 400 mm minus 0.42 into XU max is that 192 mm. So after calculating this we will get limiting moment as 88.29 kilonewton per meter. So now we will find how much, if the span of the beam is 4 meter, how much UDL is carried over through this beam we will calculate. For UDL the moment is that WL square by 8. Here we got moment, the limiting moment is that 88.29. So 88.29 equals to W. W is that into L square. The length of the span here given is 4 meter. So 4 square divided by 8. So W equals to 88.29 into 8 divided by 16. So we will get W ultimate load equals to 44.145. So this is ultimate load. So to find out the working load, we will do ultimate load by factor of safety. Factor of safety for a beam, this reinforced beam is that 1.5. So 1.5, 44.145 divided by 1.5. So we will get working load equals to 29.43 kilonewton per meter. So if you all like this video, please follow, like, share and subscribe. If you have any doubts, please comment in the comment section. Thank you all.